Okay, welcome to the Gut Club's fourth installment of our podcast. We're excited today because today we have someone with so much knowledge that I'm just extremely honored that she's here with us today. There's just so much to learn, and I'm going to be the one asking the silly questions. My name's Keith Bell. I'm the founder of the Gut Club. Today we have Christine Houghton, and because she's from Australia, there are certain ways to pronounce her last name. Pronounce your last name for me, Christine.
Houghton.
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 Houghton. Yes. Yeah.
Americans can't say it for some reason.
That's it. That's it. And being a Chicagoan, I should be able to say Houghton. Houghton. I'm going to practice that, Christine. At least I didn't say Houghton.
You did not.
No. We were, Christine and I met actually on our group page, the Gut Club Stool Test Discussion Group. It was probably about 3 years ago. The last 2 years have been such a whirlwind, due to the pandemic, that I don't think anyone can remember the last 2 years. But a few years ago, I ran into Christine on our page, and I immediately recognized greatness because she has such an ability to be articulate and understand this orchestra of what regulates our inflammatory cascades. This is so profound today in the age of COVID-19. I like to think that after this podcast, people will be able to grasp that they have an ability to take certain actions to regulate their inflammation and bring it down, so that basically the pandemic is such that the virus is leading to an immune response. Isn't that right, Christine? That is causing us to be our own worst enemies. And this is what we're going to be talking about. And this is what sulforaphane is about. We're going to be focusing on sulforaphane. This is one of Christine's areas of expertise. Christine, would you say that I've described that accurately, that we're our own worst enemies and we have the ability to regulate our inflammatory responses?
We do. I think we don't give nature enough credit. I mean, humans have been sustained on this planet for eons just using nature's toolbox. And in the last 100 years or so, we've had pharma come along and tell us, no, that doesn't work anymore, take our drugs. And I think we've been lulled into this complete, what is it? I don't know, just misunderstanding that we can't survive without having the medicines of pharma. And really, the tools are in the toolbox. Once humans conquered the hygiene issues, which were rampant in, the 17, 18, 1900s, once we got control of those, we've gotten rid of most of the infectious disease issues, and our own immune systems are perfectly capable with dealing with most of the bugs that we encounter. I won't say all of them, and I don't say for a minute that antibiotics are not necessary and other drugs, but I think we need to make them our last port of call, not our first. There are so many ways we can sustain our own health and well-being without reaching for the pharmaceutical script.
Yeah, and we live in a world that is so full of antibiotics and a toxic environment in general, that we've been reducing our ability to handle our own inflammatory responses. And
most definitely, and we look at children now who are susceptible to so many allergies. And a lot of those allergies have come about because we've continued to dampen their immune responses by giving them too many antibiotics. I remember when I was in clinical practice, I'd sometimes get parents come along with an infant and go, my child's had 8 courses of antibiotics in the last year and still he's getting these raging ear infections. Can you help me? Mm-hmm. Interestingly, those infections are not that hard to deal with when you go into nature's toolbox. What's in nature's toolbox? Food, fresh air, sunshine, sleep, rest. Just very, very simple tools. But the problem with the food element is we refine so much nutrition out of our foods that we've lost the ability to provide those nutrients that are necessary for those day-to-day repair processes that are part of good health. And once you get kids off sugar, which makes a huge difference, once you get them off sugar and start getting them onto whole unprocessed foods, lots of things start to improve. And vitamin C is not the answer. I know I'm probably the only person in the profession who does not worship vitamin C as a supplement. And we can perhaps talk about why that is later on if you like. But honestly, it's so easy to get vitamin C out of food. It is really easy. We can only absorb 400 or 500 milligrams a day as adults anyway. So why are we bucketing down gram lots of vitamin C in the mistaken hope that that's the molecule found in plants that assists immune function? What we've learned in recent decades is that there are signaling molecules that are found in plant foods that switch on protective defenses within human cells. And vitamins are not signaling molecules. They are absolutely essential for good health and well-being, without a doubt. That's a given, and a good diet gives you that. But they are not part of the nutrigenomic medicine toolbox, if you like, that protects us and switches on our protective defense mechanisms. Human cells are the most intricate little machines all in their own right. Every cell is just extraordinary. When you start digging into the biochemistry and you see all of the mechanisms which have lots of checks and balances in there, they're switching on, switching off on a moment-to-moment basis as our personal environment changes. Humans get in there and they think we can dump a whole lot of some supplement into the system, and we try to micromanage something we really do not understand and we have no ability to control.
Yeah, so the idea basically is to give the body the tools it needs to be able to heal and maintain itself. And there are many opportunities. You know, you mentioned nutrigenomics. Congratulations, I understand you've just founded the Institute for Nutrigenomic Medicine.
Yes, we have. Yes.
And by the way, I should let our audience know you're just outside of Brisbane in Cleveland, Australia. Let's see, it's Thursday here still, rather Wednesday evening. It's Thursday morning where you are.
It is, yes.
So this is just fantastic to be able to speak with you across the globe. Incredible. You know, I remember when nutrigenomics did not include the word bacteria on its Wikipedia page. That's the focus of the Gut Club, is microbial balance. And we're going to be focusing on sulforaphane, and we'll talk a bit about how it can balance flora. There seem to be several mechanisms for this. But you know, this is something that you actually include in your construct. In fact, you must, I mean, your toolbox is so tremendous, Dr. Houghton, that
I can say Bell without any trouble.
I'm very impressed, very impressed. But you know, you probably are the least inflammatory person I know, with the knowledge bank that you have. How often do you take sulforaphane yourself?
Every day.
Every day, okay.
Yeah, pretty much every day. If I miss occasionally, I don't think it does me any harm. The interesting thing about supplements with nutrigenomic activity is that they're activating a whole host of protective genes, and those genes then produce enzymes. Those enzymes recycle themselves for a couple of days. So,
They like rock and roll in Australia, I saw.
That's Santana. Did you get it?
Okay.
So when you activate those protective genes, those genes remain able to produce these enzymes for a couple of days. And so therefore, if I only took the sulforaphane 3 times a week, let's say, I still have those enzymes being active within my system, naturally diminishing over a few days. And it reminds me too that some of the earliest studies on broccoli as a vegetable that has its anti-cancer activities, there's studies by Joanna Lamp that go back, I don't know, 20, 30 years or something like that. And she says that you really only need to eat broccoli about 3 times a week. And I was curious about that until I understood that those genes are upregulated and the enzymes they produce last for some time. So occasionally, if I forget, I'll just take a double dose the next day. So
okay, how interesting. I've been experimenting with it myself the last couple of years. I've been through a few bottles. I should say that that Christine is the founder of Cell Logics, and the Gut Club is a proud affiliate of this company. In the description of this podcast, you can find a link, and if you'd like, you can receive a discount on the products. But I've been through a few bottles, and don't hang up on me, Christine, but I've tried a couple others as well. I don't take it every day, but I wanted to see if there were any differences, because not all sulforaphane products are created equally. That's a certainty. That goes for probiotics as well, of course. But I was amazed. I find that my eyesight seems to improve. I'm not, which is an obvious anti-inflammatory reaction. And sometimes, in a certain way, I thought that it actually makes me so calm that I feel a little bit dull. Not that I don't always feel dull, especially next to you. But the point is that there was an obvious effect. I'm not treating any particular health problem other than being 60 years old and having metabolic syndrome, as any good 60-year-old should. But I'm so happy to have sulforaphane in my toolbox. But for other people, sulforaphane seems to be a game changer, or should be considered a potential game changer, and should be one of the top things that people should be testing. We only have just a few affiliate programs that the Gut Club works with. Sulforaphane is one of them, for good reason, I think. What is sulforaphane? Tell us a little bit about. I think we need to get to the basics before we get into the nitty-gritty.
Sure.
Okay.
So it's a molecule that comes primarily from broccoli. In our case, we use broccoli sprouts because the precursors to this molecule are far more concentrated in the young sprout than they are in the vegetable. There's nothing wrong with eating the vegetable. It's got a whole heap of other nutrients in it, but it does have a reduced capacity to produce sulforaphane. The first important thing to say is there is no sulforaphane in broccoli or any other vegetable. And if you see a supplement bottle that says this product contains X milligrams of sulforaphane, you'll know whoever made the supplement doesn't know what they're talking about. What do I mean by that? What I mean is in the broccoli seed and the young sprout that grows from it, there's a molecule called glucoraphanin that we call the precursor, and it doesn't do anything much on its own. It sits there in the seed or the sprout. In a separate compartment within the plant cell is another molecule called myrosinase. So that's an enzyme. So those two sit there minding their own business until you break or chop or chew those plant cells. So when you break up the plant cell, the myrosinase gets in contact with the glucoraphanin. A chemical reaction occurs from that myrosinase enzyme, and that produces the sulforaphane. So the sad news about that is, if you're trying to make a supplement, is sulforaphane only lasts 10 to 30 minutes or so. It degrades very quickly. So therefore, when you're eating an intact piece of broccoli, vegetable, let's say you've got some raw broccoli where the myrosinase remains, cooking kills it. You chew it, you're now chopping up all those plant cells, you're producing sulforaphane in your mouth, you're swallowing that. it's getting into your digestive tract and doing whatever it needs to do thereafter. So you have to actually produce the sulforaphane along the way. So if you had a powdered vegetable, a powdered broccoli or a powdered broccoli sprout, hopefully whoever made that product has kept moisture away from that powder. So when you stir it in a glass of water, now the enzyme and the glucoraphanin come in contact, and so now you make the sulforaphane. You drink that, and so you're now getting the benefits of it. So that's really important to understand, because in the early days, the broccoli sprout supplements that came onto the market had no enzyme, and still a large number of them have no enzyme. So what they did is they took the seeds. They're not actually even sprouting. They're using the seeds. They extract the glucoraphanin precursor from the seeds, and that's what goes in the supplement. So it has no ability of its own to produce sulforaphane. And I think people would have taken these supplements and become very disappointed in them, because when you looked on the label said this product contains so many milligrams of sulforaphane glucosinolate. There's actually no such chemical entity. It's actually the glucoraphanin precursor that it contains. And because the consumer saw this word sulforaphane there, they're going, oh, that's the one I want. So that's what they took. And they simply don't work apart from about 10% myrosinase activity that can come about from having certain gut microbes. So various bacteria living in the gut have some ability to take that glucoraphanin precursor and turn it into sulforaphane. But it's about 10%. So it's in no way a substitute for, having the intact plant that's got the myrosinase and the precursor in it.
Yeah. The precursor, glucoraphanin, am I pronouncing that correctly? That's a mouthful. Glucoraphanin. Yeah.
Glucoraphanin, yeah.
Glucoraphanin, yeah. That, is that also in arugula, which can then be converted to erucin, which is an analog of sulforaphane?
So if we just take a step back, all of the cruciferous vegetables have precursor molecules in them that are like glucoraphanin. So the arugula has glucoerucin, cabbage has cinegrin, so on and so forth. So they all behave, they all have the myrosinase enzyme, but they don't all have the same precursor. So therefore, what they produce is a little bit different from sulforaphane. So I'm glad you mentioned arugula, or rocket, we call it here in Australia.
Yes, yes.
It grows like a rocket anyway. And so it produces erucin as its version of the sulforaphane. Now, the cute thing about that is, and a group headed up by John Clark some years ago published a paper on this that looked at the fact that sulforaphane and erucin are actually interconvertible. So if you eat one, you can get the benefits of the other. Now, I don't know that that's been well explored in a research capacity since that one paper. But nevertheless, I think there's a great deal of benefit in people trying to include as many cruciferous vegetables into their diet as possible. There are, other plants like red radish, the white Japanese radish, daikon, which also contain this family of active molecules. The reason we focus on sulforaphane is it has a very high potency, and it's probably had by far the most research done on it compared to the other similar molecules in the cruciferous vegetable family. But I'm sure, ideally, as we should do with diet in general, try and eat a diversity of different foods and try and get as many crucifers into the diet as possible. Better raw than cooked. And of course, with rocket or arugula, we do eat it raw, whereas with broccoli, we tend to cook it. And the enzyme is not heat stable. So you kill the enzyme when you cook broccoli vegetable.
Right. I've been referring to myself these days as an arugula freak. Not to downgrade broccoli, but it seems pretty easy to eat a large amount of arugula. I like to think of it as sort of a modified Walls protocol, where Dr. Terry Walls has this 9 cup a day high dose vegetable diet.
And a lot of kale in her diet too, which is highly nutritious, but I think it's a bit hard to eat lots of kale. And I like your idea. If you don't mind the hot, spicy taste of arugula, then that's a good one to add in.
Yeah, and it's also got, it tops the list of foods for dietary nitrates, even more than beets. That's amazing. And you know, it's also considered a lower oxalate green. So it seems to have a lot of benefits, but then again, you might have to eat a truckload of it to be able to get, you know, the yield of sulforaphane that you would get from a broccoli sprout supplement. I mean, would you have to eat a full truckload of arugula compared to 2 capsules, you know?
Well, I think the thing is we don't really know. I don't think those studies have been done. But the way I look at it is I look at prevention from a dietary standpoint. And as I mentioned, you know, the more diverse your diet, the more different plant chemicals you can incorporate. If you're looking for a specific therapeutic effect, then I think we need to look at some more standardized form. So there's a lot of clinical trials being done on sulforaphane. And so we know the sulforaphane dose that was used in those clinical trials to get a beneficial outcome. So from a clinical standpoint, if I'm treating a patient, I need to know how much sulforaphane I need to give them in order to get an expected effect. Whereas with a diverse diet, to me, that's the foundation on which everything else sits. I don't use vitamin and mineral supplements to any extent anymore, apart from, you know, particular situations that are a little different. I prefer to get the diet functioning at its peak, and it's a given. I'm going to get all the vitamins and minerals and trace elements and so on from a broad-based diet. And then I can get into some of the specific plant chemicals in order to ensure that I'm going to have the therapeutic effect that I expect. And it isn't always plant chemicals per se. I mean, I'm looking, as you are too, Keith, in your work, in trying to generate butyrate as much as I can in a patient's gut, because we know that it's the butyrate that's feeding a lot of the cells lining the gut, particularly the colon. And I can get that out of a range of different foods. I can get it out of beta-glucan from oats. I can get it from certain polyphenols. There's a new one we're looking at the moment with some formulations we're doing here, which is actually bamboo fiber. And it's a white soluble powder, pretty tasteless, cheap as chips. And so we can get a range of different benefits in different ways. And
interesting.
You can see I get pretty excited about plant foods. I'm not advocating a vegan diet or even vegetarian, not at all. But I do advocate a plant-rich diet, not what vegans call a plant-based diet.
Yeah, I haven't seen the bamboo fiber, but that's very interesting. I've seen a study about the giant panda diet. They're eating a lot of bamboo, and it's raising the Clostridium butyricum in their gut, which is producing butyrate.
There you go. We're probably talking about the same thing, except the panda's got to do a lot of chomping through fiber to get it. We've just got our white powder. Yeah.
Oh, yeah. It's probably the scientists of that study behind that product. Who knows? It could be. It could be. I wouldn't be surprised. So let's talk about how sulforaphane can balance flora. I've seen a study. It was actually a bladder cancer study. Later, I'll show you the photo. You know, actually, speaking of cancer, it's everyone's worst fear and nightmare. But you know, we've always known, you know, since we were children, that broccoli was anti-cancer. We just didn't understand the mechanism behind it. And when I learned about sulforaphane, I was able to add 2 and 2 finally and understand how that happens. And the sulforaphane was shown to raise the two major phyla, both the Bacteroidetes and in particular B. fragilis, which is a protective immune modulating microbe, as well as the butyrate producing Clostridia. So on both sides of the major phyla, it was able to raise those beneficial microbes. That's amazing. So it's not really acting on one, it's not a prebiotic we're talking about here that's focusing on particular sets of microbes. It is basically leading to, in my understanding, an anti-inflammatory cascade that sets up shop for the protective microbes to flourish. Is that, the way you see it?
I certainly do. And I mean, we talk about the germ theory versus the terrain theory, if you like. And what's interesting is there's quite a lot of work now creeping into the scientific literature that's talking about how it's the gut ecosystem and its microbes are being driven by the integrity of those cells lining the gut. So that's the gut epithelium. Those lining cells in any tube of the body, whether it's the respiratory system, the urinary tract, or the gut, they're all very similar. They're just one layer of cells, a single layer. In the gut, they have a number of specific functions that are different from cells in other organs. But quite remarkably, if we can optimize the function of those gut lining cells, and those lining cells talk to the immune system, which directly underlies them. About 80% of our immune function is actually underneath the gut lining cells. And I mean, I think people tend to think that immune function is to do with the respiratory system, tonsils and catching colds and flus and things. Yes, that is true, but most of the gut function, most of the immune function is directly underlying the gut. And there are conversations continuously going on between what's happening in those epithelial lining cells and the immune cells directly underneath. Now, there's a third player in all of this, and the third player is the microbes you mentioned, which live in that gut tube. So those are the three components of the gut ecosystem. But the new studies are showing that it's these epithelial lining cells which are driving that process. They're the conductor of the orchestra. And they have all sorts of receptors on their surface, and the microbes have signaling molecules sitting on their surface. So, for example, if you get a lactobacillus molecule, so lactobacillus is perhaps the microbe most people are familiar with in terms of it's the bugs that are in yogurt and kefir and fermented foods and so on. And we'll just use that one as an example. So on the surface of that lactobacillus bug, there is a molecule called lipoteichoic acid, LTA. And LTA attaches itself to a thing called a toll-like receptor number 2 on the surface of the gut epithelium cells. And that actually creates some pretty valuable magic in the immune cells underneath. And I don't use the word magic lightly, but it's quite remarkable. So when you get that lactobacillus molecule locking onto the toll-like receptor, that now sends signals down into the immune system, which, long story short, improves the body's ability to fight infection. It improves the body's ability to fight cancer cells. Natural killer cells are upregulated. By contrast, it reduces the cellular propensity towards allergies and also to autoimmunity. So it's a balancing act. Essentially, what those bugs do is they send signals through the gut epithelium to balance what's going on in the immune system. And I forgot to mention also it downregulates inflammation. So this is one of the mechanistic reasons that we like to be sure that we've got the right proportion of bugs living in the gut. Now, so that's the good bugs. We have bad bugs living in there too. So if we look at some of the gram-negative proteobacteria, they have on their surface a molecule called lipopolysaccharide. We sometimes call it endotoxin. it hooks onto a different receptor. And these receptors are just like little antennae that are waving around within the gut. And toll-like receptor 4 is where this endotoxin attaches. So when that attaches, that sends different signals into the immune cells underneath, and that produces inflammation that really ramps up uncontrolled inflammation. Mm-hmm. And so then those inflammation promoting molecules, cytokines and other families, we call them, they now can get transferred through the vascular system, the bloodstream, to other organs. So they can get into the liver and they can get into other tissues and promote inflammation throughout the body. So if we can now regulate the sort of bugs that are living in the gut and focus on the lactobacillus and other, let's call them just friendly bacteria, and get rid of the pathogenic or potentially pathogenic bacteria, we're now promoting health throughout the body, not just in the gut, but because we get this signaling effect that goes to every organ within the system.
Well, that's a great description. And I've been aware of LTA and LPS. This is really crucial, actually, in the day and age of COVID-19, because it's this inflammatory system that is suggestive of what I would refer to as a microbial predisposition to severe COVID-19. If you have a higher level of proteobacteria or other gram-negative bacteria, the Bacteroidetes, you may have a situation of being more prone to severe COVID-19. There is a lot of research in this area. So I think it's a fascinating thing to consider that sulforaphane has an ability to balance those, those gram-positive and gram-negative bacteria. This is a really interesting thing as well. You talk about what's happening under the epithelial lining. This is the beginning of the lymphatic system, in my understanding, and it all connects through, I think it's called the mesenteric lymphatics, which then connect to blood circulation. It goes up from the gut and the liver. All that lymphatic fluid goes up through the thoracic duct and then connects up in the right subclavian vein, I think it is. Maybe it's the left, don't quote me. And then it mixes with blood circulation. And we're sending all of these potentially inflammatory signals to our organs. And the idea is to protect our organs from damage. In the case of COVID-19, the obvious one is lung damage. And there's quite a lot of literature now I've run across with sulforaphane being considered a way of preventing and treating COVID-19. Obviously, we can't make any particular claims here, but this has been talked about. Did you want to say something on this subject?
Yes, so no, there's no clinical trials being done on that, but mechanistically it makes sense. What really distresses me, or has distressed me over the last 2 years with the COVID story, is the fact that we're hanging out for a vaccine to produce antibodies. The antibodies take about 5 to 7 days to kick in. We can so the innate immune system, so what's going on in the lining cells of the gut and the underlying immune cells, that's your innate immune system. That's working from the minute there's any hint of a bug that's in your system. If that can work properly, you can stop a viral infection in its tracks. It doesn't need to get to the stage where you need to be producing antibodies. And I think, we have this idea that, you are COVID immune if you've got antibodies in your system. Not necessarily. So if I was exposed to SARS-CoV-2 virus burden, if my innate immune system is working well and it starts in my nasal passages, my tongue, my whole respiratory tract, if that's working well, and what's going on in the respiratory tract is a little bit like what's going on in the gut, just some different cell types, but still the immune cells underlying the epithelial lining cells. are ready and active to fight immediately, and they upregulate their infection control. If that's working, I can stop that dead in its tracks. I don't need to produce antibodies. It never got that far, that it activated the second part of the immune defenses. And I think it's so unfortunate that this knowledge is just so little known and little understood. And why do some people catch infections and others don't? Well, their innate immune system is helping them. I mean, we've known this forever. We've forgotten it. Children have tonsils, and a child who is prone to infections will often have very, very large tonsils, and that's the body going, gee, I'm trying harder. Tonsils are trying harder and harder to fight an infection, but that child's core defenses are not really working as they should. We take the tonsils out. We just cut out the first line of defense instead of saying, how can we address that child's immune system? Now, you asked me about sulforaphane in that context. So if we go back to look at the epithelial cells, whether they're in the gut or the respiratory tract, we'll treat them as the same way. What sulforaphane does is it activates a switch within those cells, and that switch is called NRF2. NRF2 governs the function or the activation of about 500 or more protective genes. We don't really know exactly how many. That'll do, it's hundreds. So those protective genes act in concert. In doing that, when they activate, they produce a whole host of very potent antioxidant enzymes, which are literally capable of quenching millions of free radicals per second, unlike a vitamin C molecule, which will quench 2 or 3 and then itself becomes oxidized. It'll produce detoxification enzymes. So if there's sickness, there'll be dead cells. It needs to clean up the damage. It produces a whole lot of anti-inflammatory compounds, and it switches off another switch called NF-kappa B, which produces a lot more inflammation. So using a molecule like sulforaphane, which is the most potent known naturally occurring molecule to activate NRF2, we can get to this core process where we can start normalizing function in the epithelial lining cells. That now is going to have positive messages and signals sent to the immune cells underneath. So we start to have the ability to control what's going on in the immune system. Sulforaphane has some other specific antiviral properties that are lesser known and understood. But if we just focus on the NRF2 activation, if you can activate NRF2, you can switch on all of your protective defenses, not one at a time, but simultaneously. In my book called Switched On, I use the analogy of a Christmas tree. So you've got hundreds of light bulbs on your Christmas tree. You go over to the wall, you turn on one switch, the whole Christmas tree is lit up all at once. That's a little bit like the way in which NRF2 activates all the defensive mechanisms at the same time.
Yeah, and again,
if you never heard of sulforaphane, how does Mother Nature do this? So Mother Nature says we have lots of ways of activating sulforaphane, a diverse plant-rich diet, fresh air, sunshine, sleep, rest, exercise, all of the usual lifestyle factors that we can use for good health. They're all activating NRF2.
And again, we should emphasize sulforaphane is the most potent NRF2 activator, you said. That's
the most potent naturally occurring.
Okay.
So as you might imagine, pharma has developed drugs in order to try and mimic this process. And there was a drug developed about, 8 years ago or something called bardoxolone methyl. It had about 830-fold the NRF2 activating capacity of sulforaphane. It was put into a clinical trial on people with chronic kidney disease, and they had to stop the trial 6 months or so into it because the patients were dying. One of the things that happened causing death by heart failure is the magnesium levels substantially dropped. Now, exactly why that happened, I don't know. I'm not sure that that was investigated further, but again, it just shows we try and micromanage nature. Nature takes care of it. Those mechanisms are all there. I'm all for mimicking what nature does, not trying to second guess and outsmart nature, because nature wins always. And the bardoxolone methyl trial was a good example of that.
Yeah, well, I'm with you there, Christine. It's, in fact, you inspire me to even go further in that direction. Speaking of the of the pandemic, you're inspiring an idea. I wonder if there's been any talk of direct application to sulforaphane to the lungs, in the same way that just a couple of weeks ago I talked to a scientist who's developing a product through his own research at the University of Alabama to nebulize or aerosolize probiotics. They call them live biotherapeutics. And basically you're inhaling probiotics. Have you ever heard of inhaled sulforaphane? I wonder if that would have an effect.
You would have to stabilize it first. So there are a few synthetic forms of sulforaphane that have been stabilized as oral supplements. I don't think they've been around long enough for us to know whether that's appropriate action or not. Theoretically, if you could get sulforaphane stabilized into the respiratory tract, the mucous membrane would moisten the environment. The sulforaphane would be rapidly absorbed, provided whatever they've stabilized it with allows that. Sulforaphane is quite a small molecule, and it's lipophilic, so it's attracted to lipid or fat membranes. So it goes through membranes pretty quickly. That's why it can go through the blood-brain barrier and other places that's often a barrier. So theoretically, an inhaled stabilized sulforaphane could be helpful.
Interesting. You know what? You mentioned the blood-brain barrier. Let's talk for a bit about the neuroprotective benefits of sulforaphane, the autism challenge, which is really an epidemic these days. Do you think the neuroprotective aspect of sulforaphane, and there are dozens of studies now, and also many I've seen about, the, as you say, respiratory, we say respiratory, and sulforaphane. But do you think the neuroprotective benefits are by way of the microbiota gut-brain axis for sulforaphane, or is sulforaphane?
Well, actually, I published a book chapter a couple of years ago on that very topic. So it was about the gut-brain axis, and it referred extensively to sulforaphane in that paper. Yes, with a lot of the conditions you're talking about, so autism, ADHD, Parkinsonism, a whole host of neurological disorders are associated with excessive oxidative stress and excessive inflammation.
Yeah. By the way, let me just break in and let you know that we have over 70,000 people living with Alzheimer's disease here in Palm Beach County, Florida alone.
Okay.
Yeah.
Yeah.
So
that's terrible. Yeah.
All right. So keep going.
So I liken those conditions to having a bushfire in the brain. Schizophrenia is another one. I've actually worked with schizophrenia patients where their thoughts, their minds are just scrambled. They're all over the place. Often an autistic child is like that. The bushfire in the brain is just like a whole lot of neurons that are just short-circuiting. The pathways are not connected in the way that they should for normal neural function. They short circuit. So our goal as clinicians is to reduce the oxidative stress, reduce the inflammation, ensure that detoxification pathways are working to clean up the tissue debris that occurs when that's happening. So because sulforaphane is a natural compound, can readily pass through the blood-brain barrier, and because it upregulates antioxidant enzymes very potently, and it downregulates inflammatory pathways, mechanistically we know that it can be helpful in those sorts of conditions. Now, clinically, I work with a lot of clinicians in Australia. I'm not in active clinical practice myself these days, but I teach clinicians. So we're getting constant feedback from our clinicians as to what helps and how it works. And I know that this is helpful. Now, at the end of 2014, Singh et al. Wrote a paper on sulforaphane in autism spectrum disorder. And their clinical trial was using a whole stack of markers for, like, behavioural markers for autistic children. The data were fairly impressive. They kept the patients on the intervention, which was just sulforaphane. It wasn't combined with any other diet or lifestyle interventions. So it's a big ask for one little food supplement just in isolation to change such behavioural characteristics. So I think it was 18 weeks they ran the study for, and they recorded a whole lot of behavioural improvements in concentration, socialisation, verbal skills, and so on. When they stopped the sulforaphane at the end of 18 weeks, those patients gradually resumed their prior condition, which was rather unfortunate. I think they ran that for about another 4 weeks, and then they cut off recording at that time. So they hadn't gone back where they started, but clearly they weren't getting any sort of a cure, but they were certainly getting better management. And from my perspective, I think if we took that same intervention and put it in the context of other diet and lifestyle characteristics, I think we would get, well, I know we do, get much better response. The problem you have with something like sulforaphane or broccoli sprout powder is it's not a pleasant taste for an adult, and it's certainly not something a child, and especially an autistic child, is going to be happy to take. So we did a little bit of work in our lab here, and we decided if we could camouflage that taste, we'd probably be able to get kids to take it. So we used some natural pomegranate juice, some coconut water, and some vanilla. And we found that we could camouflage that taste.
That's this product, yeah.
That's it there, Pomgenics.
Pomgenics, yeah. Okay.
So, and kids would take it. So they could stir it into water, or they could stir it into milk. But some of them discovered that if you just ate it straight off the scoop or the spoon, it was like an old-fashioned sherbet powder, and they quite happily had that as their little treat once a day.
I can tell you from personal experience, it's quite delicious, actually. I think it's also beneficial because, unlike a capsule, you can titrate the dose. You can, in fact, with anything new, it's wise to begin with a very small amount. And I would say this also applies to sulforaphane.
It especially does, Keith. It especially does. Can I talk about the gut effects there?
Please. Yeah.
So when I first started working with broccoli sprout supplements and powders and so on, I'd find every so often someone would call me and say, oh, that stuff really makes me sick. I can't take it. I threw it out, whatever. And I thought, why is that happening? What is it? So little by little, we began to piece the story together. And what we discovered, although not confirmed clinically or not confirmed in terms of any statistical analysis, is the patients with the most severe gut dysbiosis seem to get a die-off effect from sulforaphane, which makes them very uncomfortable when they start to take the full dose. So we know that the gut epithelial cells produce molecules called defensins, alpha defensin, beta defensins, and those are natural antibiotics, if you like, antimicrobials. They're selective, so they don't kill off the good bugs. They simply kill off the bad bugs, and this is a perfect solution. We don't want to be giving antibiotics because we can't control which bugs get killed off. So sulforaphane appears to target the pathobionts or whatever it is that's causing this severe dysbiosis. Now, those patients will already know they get lots of bloating and pain and discomfort and irregularity and so on. They know they have something wrong. When they take the full dose, they can get some die off of these bugs. Those bad bugs now are dumping their own waste materials into the gut. Yeah. Some of that gets taken up into the system. So they feel sick, they feel seedy and horrible. That's the worst case scenario. Doesn't happen very often. Mm-hmm. The problem is very easily solved because what we do is we ask them to get a sharp kitchen knife with a sharp tip on it and just take the tip of a sharp knife blade's worth of powder once and see how they go. And they're normally not going to have a reaction to that. That evening, take another sharp knife blade's bit of powder and gauge how you go. Every day, gradually creep up that dose, titrate the dose until you get up to the full gram of powder, which is 1 scoop of the one that we use. Takes about 2 weeks. Sometimes it can take longer in the more severe cases. But those people who react, what they've really just done, they've diagnosed their own gut dysbiosis, whether they knew they had it or not. They may or may not have had some sort of microbial analysis to determine what the proportion is in the gut. But that seems to sort it out. And then once they've got that under control, now they can start, they're at the same time doing work on the gut epithelial cells, upregulating these antioxidant enzymes, the detox enzymes, and downregulating inflammation. So that's how we titrate the dose. And it's important to know when you start it that if you have a reaction like that, you just back off the dose. You don't flush it down the toilet or any of this other nonsense that people tell me they do if one dose disagrees with them.
Yeah. Well, thank you very much for that explanation. That's really important so that people don't become discouraged. I didn't have any adverse reaction whatsoever. I've taken it dozens of times now. But for someone with a severely imbalanced gut, I can see how that can be problematic.
Yeah. So most people don't have a reaction, but we're dealing with clinicians all the time. And of course, they're dealing with sick people. And a lot of those sick people have gut problems. Yeah. And if we're talking about autism, autistic kids typically have gut problems. It's so common. Yes. So we just creep it along slowly and little by little, we find the dose that's satisfactory for them.
Makes sense. You know, the example I give to people, even with kefir, I say they need to begin with only a tablespoon dose to avoid an adverse reaction. And, you know, I like to ask the question, do you know the cure for peanut allergy? Do you know what that is? It's small amounts of peanut, basically.
Yes.
Right? Yes. Okay. Let's go through a little bit of the research that we've been compiling. I want to share my screen and then we'll wrap things up. We've been talking for quite a while here. But before I get to that, I wanted to mention you've inspired another idea. I saw a new piece of research with fecal microbiota transplant, FMT, where the donor was given a prebiotic. I forget which type. It was a brown algae oligosaccharide, alginate. I'm not sure the name of it right now, but this shifted flora in the donor, and then the FMT donor material was more effective. Sulforaphane might be good for donors. Just a thought.
Well, I mean, to be honest, I think so we teach the GEM protocol here, gut ecology and metabolic modulation, and it's designed to restore homeostasis to the gut immune interface. And so following on with where you're going with the prebiotic it would be a good idea, I think, for anybody who's contemplating being an FMT donor to run through the GEM protocol and try to optimize function. I mean, not all these FMT donations work as expected, do they?
No, in fact, some people are damaged.
Yes,
by some of the protocols.
And they can't seem to get back from that. So it's a little bit worrying.
Yes, it is, especially in the age of COVID and viral replication in the gut. You know, as far as I know, none of the vaccines, I think we can say that word, have been shown to halt replication in the gut. But what we're talking about here is what I like to think defines natural immunity. And hopefully we'll learn this lesson in the pandemic about, what natural immunity really means. If we miss out on that lesson, then I don't know what to say. Why don't I share my screen real fast? We'll run through a few things. Let me find it here. Oh, hold on. I've got to start over. What I want to show you is, firstly, the Gut Club Facebook page. What we do is we post photos, and then in comments underneath the photo, we have our tally of research about a given subject. This is where we keep all of our sulforaphane information. And and basically, this is the paper I mentioned earlier on bladder cancer and how sulforaphane raised B. fragilis and Clostridium. And here you see the NRF2 regulation taking place and how that impacts cancer. There must be dozens of sulforaphane cancer papers these days.
Well, preventively, yes. Therapeutically, no.
Yeah.
But I see there on the right side of that slide, sulforaphane reducing interleukin-6. And there are other studies that have been done. So that's one of the inflammatory cytokines. And there's other studies done which have shown that it reduces other inflammation markers like C-reactive protein, interleukin-6, TNF-alpha. So we know it has an anti-inflammatory effect. That's going to be beneficial on the tight junctions, which are also shown there between the cells. In a severely inflamed gut epithelium, those tight junctions get very loose, let's say, and they allow the migration of undesirable bugs and molecules from the gut lumen or the tube down into the immune system underneath and subsequently onto the rest of the circulation. So that anti-inflammatory effect would be very potent there, but we're also going to be using the beta defensins as well, which are going to encourage the growth of the desirable commensal organisms and discourage, if you like, the pathogens. So there's probably a number of different actions that are occurring there. The other thing that sulforaphane does, and it's basically in Helicobacter, which is up in the stomach, it inhibits urease. So, and I won't labour on that, but you'll see where I'm going in a minute. So if you can inhibit the urease enzyme in Helicobacter in the stomach, you will get rid of a lot of the population of Helicobacter. Now, there are other urease positive organisms like Klebsiella and Staph aureus, which are also harmful in their own right. It would be interesting to know whether sulforaphane actively inhibits Klebsiella and so on because of that urease inhibition effect as well. That's something that no one has yet explored, but it's also worth considering because the mechanism would seem to indicate that that's another action that it has at that level.
Interesting. It may also be about raising butyric acid, which signals the colonocytes to mop up oxygen and lowers those aerobic proteobacteria like Klebsiella. I wonder, that would be interesting.
Yes, and you know, as you know, I'm very keen on using the gut epithelium as the driver of the population of microbes that are in the gut, and that's a really nice paper in 2018 by the author Litvak, says the colonocyte metabolism shapes the gut microbiota, and that's the paper which does talk about the way in which butyrate is essential to provide the energy source to those colonocytes in the colon in order to consume the oxygen so we can encourage the growth of the anaerobes and not the aerobes.
Right.
So to me, I call the gut epithelium mission control of the entire gut ecosystem, because I think our work with clinicians and patients here in Australia has certainly confirmed that if we regard the gut epithelium as mission control and start treating with sulforaphane, a lot of other things will fix themselves as a consequence of that.
Yes, it's an anti-inflammatory cascade that, that, as I said earlier, sets up shop for repair. How interesting. I want to show people your 2019 review paper, Sulforaphane, Its Coming of Age as a clinically relevant nutraceutical in the prevention and treatment of chronic disease. There's a lot here for people to go through. So that's Christine, how do you pronounce it?
Houghton.
Houghton, of course, Houghton. Very good. Let's see what else we can go through here. This was a paper March 2022 about the antiviral activity against SARS-2.
Yes, so that one's very recent, of course, just March this year.
Yeah.
It talks about it's sort of more indirectly antiviral in its discussion. So it's talking about the anti-inflammatory, antioxidant effects. So to me, this is about upregulating NRF2 and taking advantage of all of those 500 or so protective genes, even though the paper doesn't talk about that. That's really its message. And then it's gone ahead and shown too the way in which sulforaphane increases the activity of the phagocytes within the alveolar, so alveolar tube. So basically within the lungs, the macrophages are like the Pac-Man cells of the immune system that run around and gobble up viruses and bacteria and other molecules that shouldn't be there. So it showed that sulforaphane actually upregulated that phagocytic ability of those macrophages in order to basically engulf and get rid of viruses that happen to be floating around.
Yeah.
And I don't think that's any specific antiviral effect. It's just that, again, it's improved the function of those immune cells by activating NRF2 in the same way that it improves the function of every cell in the body by activating NRF2. But it's nice to see some of these papers coming out now that are starting to look at what's mechanistically serious therapy, preventional therapy. I mean, I'm a little bit tired of seeing people recommending vitamin C, vitamin D, quercetin and zinc as the go-to therapy to prevent or treat SARS-CoV-2, when there isn't any evidence for this. It's kind of doing the rounds of everybody who's talking about it. They just keep repeating the same thing. Now, there's good reason to talk about zinc, and there's good reason to talk about vitamin D. Vitamin C in high doses actually blocks NRF2. So I am never in favour of using high-dose antioxidant vitamins like vitamin C and vitamin E, and I'm not in favour of using NAC either, N-acetylcysteine, because they are direct inhibitors of NRF2 activity. So you don't upregulate your defensive molecules. This is old last century science that started back in the 70s. I mean, it started with Linus Pauling and it's really never been updated in the supplement arena. It needs to change. It needs to be updated. Yeah. I did a seminar last year on allergies for our clinicians here. And essentially, when I was doing the research on putting the presentation together, I was able to see that the natural medicine professions stopped talking about immune function, new information about the early 1980s. They have just continued on with the same story. What I mentioned to you earlier on about toll-like receptor 2 and toll-like receptor 4 as being part of the signaling system that tells the immune system what to do. None of that is being taught in these modern curricula. So when I talk about nutrigenomic medicine, I call it the medicine for the 21st century because things have changed.
Yeah.
You know, it's like using bucket loads of vitamin C because you want an antioxidant. Cells don't work like that. They really do not. And it's now the era of the phytochemicals that are signaling molecules with nutrigenomic activity. That's where the science is going. And the supplement industry and the natural medicine professions, in my opinion, need to catch up and they need to update. I mean, I practiced like that. I left clinical practice in 2004 and I believe that story, but there's no way I could go back and do that now. It's not necessary and it's quite frankly wrong. The science is wrong and it needs to change.
Yes. Related to what you just said, I've seen some science in the last couple of years about SARS-2 actually binding to TLR4 as well as proteobacteria. So, yeah.
Here's something else that's interesting. I'm sorry to butt in there, Keith. I don't want to forget this.
Okay.
So we talked about the gram-negative proteobacteria attaching to toll-like receptor 4, and then that's going to initiate an inflammatory response. There's some papers that show that sulforaphane actually interferes with the function of toll-like receptor 4. So even if you have a lot of endotoxin within the gut, it can't all attach itself to the toll-like receptor 4. And so therefore you minimize some of those adverse signaling effects which drive the immune system in a pro-inflammatory direction.
Yeah. All right, let's whip through these things here. This is the paper from the photo about bladder cancer. Here's another paper about NRF2 being a strategy against COVID-19.
Well, there are some other mechanisms. This one's talking about suppressing Th17.
Yeah.
So Th17 is more associated with autoimmune function, although there are some newer discoveries, what's this one, 2019, yes. So there are some new functions there, but the way I see the T helper cells, so we largely have Th1, which is infection control, Th2 is about allergy, Th17 now supports infection control and it's associated with autoimmunity. To me, what nature is doing is stabilizing, maintaining homeostasis within those T helper cells. I don't believe we can pretend to drive these molecules in one direction or another. So this particular study is showing that sulforaphane is having benefits in autism-like symptoms by suppressing Th17 related signaling.
Right, and I've put a lot of focus on Th17 and IL-17A related to vaccine safety. This is probably the main theme of the microbiome vaccine safety project. That's what I like to call the teeth of the gut club. That and also the gut brain epilepsy project. By the way, sulforaphane also applies to epilepsy. But there's plenty of research indicating that there's a microbial regulation of immune response, especially regarding Th17 response, and which is a major inflammatory response.
And remember, with epilepsy, it's another example of a bushfire in the brain.
Yes. Oh,
neurons are short circuiting.
Yes, more than anything. This I thought was a nice 2009 headline. That you referred to these enzymes.
This is a very useful paper. Yes, so Rydell's work gave us the opportunity to look at therapeutic doses too, and we're looking at around about 20 milligrams sulforaphane a day from his paper that was active. and I think it was looking at motor vehicle exhaust fumes and the ability of sulforaphane. So phase 2 antioxidant enzymes are actually the detoxification enzymes. So by upregulating those detoxification enzymes and simultaneously antioxidants in the upper respiratory tract, the effect of inhaled motor vehicle fumes, oxidant pollutants it talks about there, you're minimizing the pro-inflammatory effect of those. So again, really good preventive medicine.
Yeah, fantastic. This is another paper focusing on autism and irritability. Sulforaphane was helpful there. By the way, I forgot to ask you, do you know anyone with COVID, long COVID, the long haulers, applying sulforaphane to their predicament?
I do. So some of our clinicians are working with the combination of sulforaphane and a lactobacillus. So this is a heat-killed lactobacillus that we use to activate the toll-like receptor 2 pathway. So sulforaphane combined with lactobacilli have the ability to restore that balance. Look, it makes sense. What is long COVID? It's a chronic condition whereby the system has been so badly turned upside down. Homeostasis has been lost within all of the epithelial cells and the immune cells and probably every other organ within the body. If you can restore homeostasis doing the things that we talk about by upregulating all those protective genes, you will get that benefit. And we've had feedback from quite a few people who have actually done this clinically. That's on the foundation of a good diet, mind you. With me, it's food first. We are very strong in our food first approach. If you don't get diet and lifestyle right, you're fiddling around trying this pill, trying that pill. It doesn't work like that. Yeah,
I really like that you promote fermented foods like the lacto-fermented vegetables and making your own kefir. I'm always impressed by that.
We encourage our clinicians to teach that to their patients as well. Not everybody's going to do it. We know they won't do that, but it doesn't stop us talking about it. We just have to be a little bit careful with those patients who seem to have a lot of histamine-related food intolerances and so on, that they find they can't take the fermented foods because they get an exacerbation, because a lot of those fermented foods do produce histamine. Food intolerance is an area that will respond very well to our approach because the reason people are intolerant to a whole lot of food. So these are not allergies you're born with. These are people who find as the years go on, I can't eat this, I can't eat that, my list keeps growing and I get all these gut symptoms that stop me, and other systemic systems as well, like skin rashes, etc. Once you restore homeostasis to the gut immune interface, same story, that will go away. And the reason people get these intolerances is they're sending scrambled messages through the gut epithelium to the immune cells underneath, and the immune cells are acting in a pro-inflammatory manner, and they just create all of this inflammation. There's an enzyme called diamine oxidase, DAO, which is produced by the gut lining cells in order to break down histamines. So histamines that you might produce within your body and histamines you might take in with food are broken down by the DAO enzyme. Once you restore homeostasis, that enzyme starts to be produced again. With all the inflammation that's there, they don't produce it. So I see people are trying to buy supplements of DAO and they're available on the market. But that's not your solution. That's a Band-Aid. Once you restore homeostasis to the gut and its underlying immune cells, those food intolerances, by and large, will disappear. And we do this all the time with our clinicians.
Yeah, that makes a lot of sense to me. This is a 2018 paper, briefly, about protection against lung injury. So
Well,
again,
it's another example really of the mechanisms we've been talking about, isn't it?
yes, yes,
Yeah.
Um, this is another anti-cancer paper.
I think that is an in vitro study, isn't it?
I have to remind myself and look at it later. I just think it's
because the epigenetic mechanisms are not so easy to achieve with sulforaphane in the doses that are available to us. I think you'll find, if that's what I think it is, I think it's an in vitro study, and the doses to get HDAC inhibition, that epigenetic mechanism, I see written down the bottom of that abstract, is a fair bit higher than we can achieve through sulforaphane supplementation. But you would also know, Keith, that butyrate is also an HDAC inhibitor.
yes.
So again, instead of trying to look at this one pill for one disorder, again, it's back to this diverse dietary foundation and a range of different interventions, and nature will sort it out for us.
Yes, yes. This was counterintuitive.
Yeah, that confuses everybody.
Yeah.
And the reason for that is when you take sulforaphane into your cells, it binds initially to glutathione, and that effectively depletes the circulating glutathione. So it soon recovers thereafter. But it causes a lot of confusion because people think this is a bad thing. We want to increase our glutathione. We don't want to decrease it.
Right, right.
Because sulforaphane via NRF2 upregulates the rate-limiting step in glutathione production, an enzyme called CBS. There's two enzymes actually which are associated with glutathione production. So it'll bind initially. Then it has to upregulate the genes, then it'll start increasing glutathione production thereafter. So you get an initial dip. It's short, it's half an hour or so, it's not a long time.
Okay.
But yes, that needs explanation.
All right, let's go to the next one here. Thank you for explaining that, because that was confusing. So here we have alleviating retinal cell death. So this goes back to my eyes seeming to benefit from sulforaphane. And
so the NLRP3 inflammasome, there's a fair bit of work being done now on sulforaphane inhibiting these inflammasomes. So this is a pro-inflammatory collection of different protein molecules that form part of the immune layer that underlies the gut or underlies any epithelium. So this specifically shows that not only does sulforaphane inhibit NF-kappa B that produces inflammatory cytokines, it also separately inhibits the NLRP3 inflammasome, which is a more complex little inflammation protein bundle that's within the cells. It's just reinforcing the same argument. That's within the retina. Yes, whether that's happening with you or not, who knows? But
well, there are some suggestions that sulforaphane could be something that could prevent glaucoma, for instance, which is a global scourge.
And associated with oxidative stress and inflammation,
exactly.
As are cataracts.
Exactly, exactly. This is very fun to consider, making your own sulforaphane by making a fermented broccoli puree using lactic acid bacteria. I think I may have to test this theory here. We think that, we talked about this earlier, Christine, that you mentioned that the sulforaphane is transitory, and so we don't know.
So you could use the bacteria to convert the glucoraphanin into sulforaphane, because certain species do have myrosinase-like activity.
Yeah.
We don't know exactly which ones, but it doesn't matter. So if we're able to do that, what we do know about these microbes is they have limited myrosinase activity. And from other studies that have been done, it's about 8 to 10% of the conversion efficiency that you get from the native myrosinase that's actually in the plant itself. The problem with this is once you produce sulforaphane, somewhere between 10 and 30 minutes for it to be absorbed into your cells to do what it needs to do, because it degrades very quickly. So there is a supplement on the market where they proudly claim that their product contains fermented broccoli or fermented broccoli sprout or something like that, and implies that it produces sulforaphane. It's practically zero. It's so small. It's a waste of time. And I mean, that to me cements the concept that you can't ferment something to produce sulforaphane and expect it to be active unless you've got some way of stabilizing it. And once you're stabilizing it, means you've got some sort of intervention, some laboratory technique to stabilize it. I prefer to focus on the whole intact natural food source rather than tinkering around too much with the chemical structures.
Yes, well,
so I have my doubts about that unless you were able to consume that very quickly, which you can do in a home environment.
Yeah, so well, I think I'll chop up some broccoli and throw it in my kefir for a couple of days, and if you don't hear
Try
from
and see,
yeah, if you don't hear from me, call the fire department. Okay. A paper from 2019 about the neuroprotective mechanisms of sulforaphane. Just showing you this for the headline. Here's an epilepsy 2015 paper by way of improving mitochondrial function. How interesting.
Well, there's some quite good research on mitochondrial function. Sulforaphane actually increases mitochondrial biogenesis as well. So that's where you produce more mitochondria as required. Our bodies increase our mitochondrial population as we need them. So in somebody who's actively exercising, they need to be able to produce more mitochondria on demand, because that's what they're producing their ATP as their energy source from.
Yes.
And sulforaphane protects the integrity of the mitochondria. I might just say this too. So if mitochondria, the energy powerhouses of the cell, are in a pro-inflammatory environment, those mitochondria will actually burst and they're no longer useful. A paper I was just reading a couple of days ago is showing how the mitochondrial membranes are stabilized. And this is an NRF2 activation story. They're stabilized by sulforaphane via NRF2 to stop them bursting. So even in a somewhat inflammatory environment, they're going to be protected for longer before they're damaged.
It's quite profound. Lastly, brain mitochondria paper.
Well, that'll be the same as I've just mentioned to you.
Yes.
The more we can protect these delicate organelles within cells, the better the chance we have of prolonging survival and promoting repair and recovery.
Yes. Dr. Houghton, I think I'm going to get this one day. Thank you so much. It's been a pleasure and an honor to speak with you today. And I look forward to continuing our conversation via cyberspace.
Yes.
It's just fantastic to be in your circle, in your shadow. Thank you very much for what you bring to this world. And I will see you in cyberspace.
I very much appreciate the opportunity, Keith. It's been a pleasure, and it's just nice to chat about some of these things that gladden my little heart anyway. A bit nerdy, of course, but you know, when you put it into practical application, it becomes really exciting. The possibilities are really exciting.
Yeah,
so
they are.
Thank
they
you
are.
so much.
Oh, thank you too, because you've given us a window into controlling our inflammatory status. And this applies to everything, doesn't it?
It does.
Yeah.
It does.
Thank you, Dr. Houghton.
Thank you.
Take care. Stay well. From
Thanks.
Palm Beach County with love.
To Cleveland, Australia. Thank you, Keith.
Thank you very
Bye-bye.
much. Bye-bye.